All right, so now in Module 6, we're going to actually get into solving these one-step equations. So in Section 6-1, we more talked about, okay, here are possible solutions, check to see which one is a solution, or check to see, is this a solution to this equation, okay? Which is still something we can use here when we get our solutions to our equations. We can check to see if the solution is right, but now we're going to be more talking about, okay, so how do we actually go through the process of solving this equation? So today specifically, we're going to be dealing with one-step addition equations. So that means that original equation is going to be addition. That means it's always going to be the variable plus something equals something, or some number equals the variable plus something. That's what makes it an addition equation. I'm adding something to my variable. So on example 1, we're purely just going to be writing the equation, not actually having to solve it. And whenever I mention solving an equation, solving means figuring out what the variable needs to be. What does a variable have to equal to make this equation be a correct mathematical equation? Okay, so on A, it says on Monday and Tuesday, Daniel's service group collected 48 4/10 pounds of cans for recycling. The group collected 23 pounds of cans on Monday. Write an addition equation that could be used to find the number of pounds Daniel's group collected on Tuesday. So back when in Module 5, when we were writing algebraic expressions, we talked about a let step, or defining a variable. So this equation I'm going to use to help determine how many they collected on Tuesday. So that is my unknown. So I'm going to need to start this by saying, well, this is my unknown. I'm going to use a letter to represent it. So I need a let step. So I'm going to do let, and again, the variable here doesn't really make a difference. It's always good to have one that makes sense for the situation. It's how much they collected on Tuesday. So I'm going to do a cursive T so it doesn't look like a plus sign. And I'm going to say, I'm just going to write Tuesday beside that because that's going to represent how much they collected on Tuesday. And then I can start writing the equation. So I know T is Tuesday's amount. They collected a total of 48 4/10 pounds. So I know it's going to have to be something equals 48 4/10 pounds because that's the total, right? And remember, I'm writing an addition equation. So yes, I might sit here and think, well, to solve it, I need to subtract. But it said to write an addition equation. So that's the original equation before I solve it. So if I look back at this, well, how do I get a total of 48 4/10 pounds? You combine what he got on Monday, which was 23, and what he got on Tuesday, which is T. So I'm going to take T plus Monday, so 23, and that needs to equal that 48 4/10 pounds. Okay, that'd be my equation. It did not tell me I needed to solve it, so I stopped there. All right, B, a couple went on a 27 5/10 mile hiking trip through the Appalachian Mountains that took 2 days. Day 1, the couple hiked 15 2/500 miles. Write an addition equation again that could be used to find out how many miles the couple hiked on day 2. So again, that's my let step. I don't know how many miles they hiked on day 2. So let, I'm just going to do D, and I'm going to say that represents day 2. That was the miles for day 2. So again, I'm going to go through this. So they hiked a total of 27 5/10 miles. And just to show you it doesn't always have to be this way, I'm going to set it up a little differently. I'm going to put the 27 5/10, the total, on the left, but it's still going to be that equals, well, that equals the day 1 miles, which was 15 2/500, plus the miles they did on day 2, which we don't know, but I said was going to be D. So plus D. Now, of course, could I have written this more like I wrote that one? I could have. They're the same thing. Whether I write D plus 15 2/500 equals this, I'm going to get the same answer regardless. Okay, moving on to starting to solve. We're going to solve these equations kind of in 2 different formats. One, I'm going to have you use a proof to kind of prove, to show each step, why we can do each step. And the second, we're just going to go through and we're going to show the work and we're going to get the answer and maybe not need to say why I can do each step. Remember, when you're solving an equation, the goal is to get what the variable is. So like here, I'm filling out this chart. My goal is step 3, I better be able to tell you K is equal to this. On B, I better be able to tell you that U is equal to this. When I'm able to tell you that, my equation has been solved. So when I look at this right now, the original problem is k plus 9 equals 20. I want to get to k equals. What's in my way is that plus 9. Okay, so how do I get rid of plus 9? Well, I need to make it go away. So I need to think about what's the inverse of adding 9. Well, the inverse operation of adding is subtracting. So I'm like, well, if I minus 9, I can get that plus 9 to go away. But always, it's a balance. An equation is a balance. When I minus from one side, I have to minus from the other. So then that tells me if I minus 9 from the left side of the equal sign, I also have to minus 9 from the right side of the equal sign. So then we're going to go over here and we're going to look at this proof sheet that I'm either going to hand out to you in class or I've already handed out to you and say, well, what property is it that tells me that I can do that minus 9 as long as I minus 9 from both sides? Well, if we look at that, it's the subtraction property of equality. Look, that as long as I minus on both sides, that equation remains balanced. So I'm just going to use this little code over here. So it's subtraction property of equality. So I'm just going to write SPE to say that's the property that I'm using mathematically that tells me I can do that. Okay, when I do that, I'm going to be left with, well, 9 minus 9 is 0. So I'll be left with k plus 0. 20 minus 9 is going to be 11. Okay, well, so what properties did I use to say 9 minus 9 equals 0? Okay, I'm going to be looking more down here at these properties in that second area. And it looks like when I take a number minus itself, that's the additive inverse property. So that's the AIP property. So when I said I knew 9 minus 9 was going to cancel out, it was going to be 0. That's the AIP, the additive inverse property. And I did two things here on this property, right? I also took 20 minus 9. Now that one's nothing fancy. That one's just called, there was nothing special there. I just said, well, 20 minus 9 is 11. That's the substitution property. So I'm also going to put sub there because I used two properties to be able to get that answer. I knew that 9 minus 9 would have to be 0 because of the additive inverse property, and then 20 minus 9, I just knew it was going to be 11. Next, well, k plus 0. Any number plus 0 is really just itself. So k plus 0 really would be the same as k, and then equals that 11, right? Well, I look at this again. We're not dealing with these ones, we're dealing with these bottom ones. What property tells me that anything plus 0 has to be itself? Well, look right here at my example. X plus 0 equals 5 is the same as x equals 5. So that would be the identity property of addition, because we're doing addition, so IPA. So that is the mathematical property that told me that even though my equation was k plus 0 equals 11, it's actually the same as k equals 11. Okay, now our next one, we're going to do kind of that same process. I look over here, I find u. Well, right now I have a plus 4 there. I really want to get to u equals, so I need to get rid of that plus 4 so that way I can tell you what u is equal to. So to do that, it's a plus 4, so I need a minus 4. If I minus 4 from the right, I got a minus 4 from the left. Again, what property is it that tells me I have to do that? That's that same property. It's the subtraction property of equality. And remember, we've got this all on this sheet. We've got examples of it, and we've got what the codes are here too. Now, 13 minus 4, that's going to be 9. The u drops down, and 4 minus 4, that's going to be 0. So I'm still going to have a plus 0. Again, what properties did I use there? Well, to do 13 minus 4, I would have just used substitution, right? Nothing fancy. I just substituted in the correct answer. To do 4 minus 4, though, that would be that additive inverse property again, that realizing that if I take a number minus itself, it's going to be 0. So additive inverse property. And then again, realizing that u plus 0, anything plus 0 is itself, so that's the same as just u, and then I'm left with 9. And so that again is the identity property of addition. Okay, now the reason I'm having you go through and do that is just because you're going to do the same thing here on example 3. You're just not going to go through and say the properties. I just wanted you to get in the habit of knowing we're not just doing this because we want to. There are actual mathematical properties that say it's okay to do this. And this is why this works. Okay? So example 3, we're going to go through that same process. We need to show work like what I did up there. Now the additional thing we're going to do other than writing the properties is we're going to check our answer, which I'll talk about. So same process though. I need to get my variable by itself. So right now I'm adding 4 to A. I need to get rid of the plus 4. The opposite of adding 4 would be to minus 4. If I minus 4 from the right side of the equal sign, I got a minus 4 from the left side of the equal sign. 10 minus 4 would be 6. Now, if I wanted to, I could show that step I showed there. Since I'm not going through that formal process of using that 2-column proof, I'm not going to show that. I'm just going to cross it out because I know 4 minus 4 is going to equal 0. That A drops down. And look, I've got A by itself. A is equal to 6. That's my solution. I showed my work. Now for the checking. The checking is to take what you say A is, put it back into the original problem for A. So according to this original problem, 10 needs to equal 4 plus 6. If my answer is right? I said A is 6. So if I put 6 in for A, it better equal what it says. Does 4 plus 6 equal 10? Yes. So that's my check. I know my answer is right. And you're going to get points for showing the work, getting the right answer, and checking it. So you need to do all those things. And again, I realize these are one-step equations, one-step addition equations. You could probably do this in your head, but again, it's more about the process. When we're doing one-step equations, it's about understanding the process because we're going to do a lot harder equations than this when we're in 7th and 8th grade. Okay. B, I look, it's 7 plus C equals 9. I need to get C by itself. What's happening to C right now? I'm adding that 7. So the opposite, the inverse, would be to subtract 7. If I subtract 7 from one side, I subtract it from the other side, which is very repetitive. 7 minus 7, again, it's going to equal 0. I'm just going to cross it out because I'm going to say it cancels out. Drop that C down, drop my equal sign down. 9 minus 7 is 2. So C is by itself. I'm saying C is 2. Check it. Plug that 2 in for C. So I'm going to check to make sure that 7 plus C, which I said was 2, needs to equal 9. Does that equal 9? Yes, it does. So I know my answer is right, without a doubt. C, it looks like I've got some mixed numbers in it. No big deal. Still same way, right? Right now, I'm adding 2 1/2 to X. How do I get rid of a adding of a 2 1/2? I'm going to have to subtract 2 1/2 to get X by itself. But if I subtract 2 1/2 from the left, I got to subtract 2 1/2 from the right. Those will cancel. I drop that X down. 7 1/4 minus 2 1/2. Remember, if you're doing this by hand, you're going to get common denominators and everything like that. But just for the sake of time, I'm going to go ahead and do this quickly. It's going to end up equaling 4 3/4. I'm going to check my answer. I'm going to take that 4 3/4, plug it in for X. So I'm going to make sure that 2 1/2 plus 4 3/4 does equal 7 1/4. Again, checking this, you're thinking common denominators and everything. So right here, I'm thinking this would actually be 2 2/4. 2 2/4 plus 4 3/4. Does that equal 7 1/4? It is going to come out to equal 7 1/4. So then I know my answer is right. Okay, and then the last one, decimals, but same concept. I'm going to have to subtract 4 85/100 over to get n by itself, right? If I subtract it from the right side of the equal sign, I subtract it from the left side of the equal sign. Take 12 35/100 minus 4 85/100. Again, just a reminder, decimals, you're lining up decimal points and everything like that. You're going to get 7 5/10 as an answer when I do that. 4 85/100 minus 4 85/100 cancels out. Drop that n down. I got n by itself, so n is equal to that 7 5/10. And again, I'm going to check it real quick. Plug 7 5/10 in for n. So 12 35/100 better equal 4 85/100 plus n, which I said was 7 5/10. So does this equal this? Yes, it does. So I know without a doubt my answer is right.